I am Dr RJothi, Assistant Professor, Department of Physics, Fatima College. I would like to share some points about optical fiber, their modes, configurations, and applications. Optical fibers are made from either glass or plastic, most or roughly the diameter of a human hair, and they may be many miles long. Light is transmitted along the center of the fiber from one end to other, and a signal may be imposed. Fiber optic systems are superior to metallic conductors in many applications. Their greatest advantage is bandwidth. Because of the wavelength of light, it is possible to transmit a signal that contains considerably more information than is possible with a metallic conductor, even a coaxial conductor. A optical fiber is dielectric waveguide that operates at optical frequencies, and it is usually cylindrical in shape. Propagation of light along a waveguide can be explained in the term called modes. An optical fiber consists of three basic concentric elements: the core, the cladding, and the outer coating. The, Let us see about the modes. When light is guided down a fiber, phase shift occur at every reflective boundary. Set of guided EM waves or modes are referred as bound or trapped modes of waveguide. There is a finite discrete number of paths down the optical fiber that produce constructive phase shift that reinforce the transmission. Only number of modes are capable of propagating along the guide. Because each mode occurs at a different angle to the fiber axis as the beam travels along the length. Let us see about the core. The cylinder is core of the fiber with a refractive index N1, which is surrounded by solid dielectric cladding having refractive index N2. The value of N2 must be lesser than the N1. In low and medium fiber loss, the core is generally made up of glass, and cladding is made up of glass or plastic. In case of higher loss, plastic core fibers can be used with plastic claddings. Gladding is not for light propagation. It is used to do the following phenomena: to reduce the scattering loss, which occur due to dielectric discontinuities at core surface, and it adds mechanical strength to fiber and protects the core from absorbing surface contaminations. Optical fiber configurations uh, is having four types of configurations. Number one is a step index a single mode, and the second one graded index a single mode, third one step index multimode fiber, and fourth one is graded index multimode. Single mode step index fiber has a central core that is sufficiently small so that there is essentially one path that light takes as it propagates down the cable. Next, multimode step index fiber. So it is similar to the single mode configuration except that the core is much larger. This type of fiber has a large light to fiber aperture. Multimode graded index. It is characterized by the central core that has a refractive index that is non-uniform. Light is propagated down this type of fiber through refraction. The respective diagram for all these configurations are given here.